Hello everyone, my name is Bing. Today I'm gonna present my project on the curves of wireless communication. My project title is the channel estimation for OFDM. So why are we starting this and who are we starting this for? We are starting this wireless network because wireless communication is rapidly developing in recent years. And since the huge increasing needs of mobile devices, so as millions of mobile devices are on the market and the number is still counting, there are enormous number of demand of wireless communication technology than ever before. It is estimated that currently the number of mobile devices are 4 times of the number of PC today shipped in 2013 market. So it is not hard to see that mobile devices would be continually increasing rapidly as new cutting-edge technology is driven by the large user demand. So apart from the mobile devices' highly user demand, we also have a very cutting-edge wireless technology, also known as the next generation of wireless communication, the 5G. And also we have this OFDM technology then can support us with this high data rate. So the three reasons are the main reason that we want to study this project and we are studying this for our own benefit in the future. There are a few related work on some of the work already have the palette arrangement and the complexity of using appropriate algorithm, and many of them have a solid mathematical proof of doing an estimation. So what we are doing here is from a wireless OFDM communication system perspective. We give a clear view of the relationship between channel minimum square error and which is the channel MSC and the single energy to noise ratio, also known as the ES over N0. So here are some preparatory work. Here, I want to introduce the OFDM technology. OFDM, orthogonal frequency division multiplexing, is much better than the previous FDM. On this figure, we can see that OFDM have lots of frequency carriers that are orthogonal to each other. So OFDM is better than past technology like FDMA or TDMA. The disadvantage of FDMA is that it has bad spectrum usage, and the disadvantage of TDMA is that it has multi-pass delay spread problem. So for OFDM, it's very efficient in the use of spectrum. So overlap in frequency spectrum of subcarriers make unique characteristics of OFDM, which is very unique. So in this water faucet analogy, we can see the differences between FDMA and OFDM. Suppose we put a finger over the outlet of the faucet. It is easier to stop the water flow in this FDM faucet, which is on the left-hand side. However, it is almost impossible to stop the water flow of OFDM shower faucet on the right. From the perspective of the principle of FDMA and OFDM, the key difference lies that when the communication channel is encountering some case of interference, the response of OFDM shows significantly robust than FDM. In other words, FDM would result in much severe or intense result if an interference occurs. So down here shows the random backoff procedure. So random backoff word in a network that can arbitrate the order of any communication. It is an algorithm that makes sure that transmission between two stations or a station to a AP access point is guaranteed to have a time slot to transmit in a network instead of all the communication happened at once, and thus lead to a collision mass and further retransmission and lead to another collision. In order to avoid this kind of a collision circle on this, a random backup procedure is introduced. And so in the example on any station, if it want to transmit, you need to have a random number between 0 to 31. So it have a initial backup, and any station who wants to transmit must have a first initial backup, and then when the routine reaches 2 to 0, it can transmit. In this situation, station 3 can transmit data after the station 1 because it only have this short of time. However, station 2 need to pause its counting down until the station 3 transmit finished. So in this game, it will transmit in this fashion order, so that it will guarantee that there will no collision happen. So the benefit of OFDM is mainly threefold. The first one is higher data rates. The second one is lower bandwidth than spread spectrum. In other words, it has higher spectral efficiency. And the third one is lower multi-party distortion because it uses cyclic prefix or the guard interval. So let's take a look at the OFDM architecture. Here we have some steps in order to simulate an OFDM communication system. The first one is we have an input to time domain, and the second one is we insert some guard interval, that is the cyclic prefix that we just saw. So it prepared the last part of the signal to the beginning of the signal. Third one is we have a channel which is a signal with the system's convolution and plus some AWG and noise. And the fourth step is when it reaches to the receiver side, we need to remove the guard interval and then output to a frequency domain, which is the inverse procedure of first doing the first step. And then we have an output which is the Y here, and finally we can estimate our channel. So in here the HK is our estimated channel. So doing the channel estimation, as we saw from the previous slide, the architecture given the channel we estimating HK. So this process is called channel estimation. So in this project, there are two approaches to do this. The first one is least square estimator, and the other one is minimum mean square error estimator, or MMSE. So after we do the simulation, we can have the following result, which shows in the figure. The right line shows the least square approach, which is in here, and the black line shows the minimum, which is here. Minimum mean square error estimator. So these two, MMSE and LSE, give us a result that shows since the ES over the anode is the single energy to noise ratio, so the result shows the relationship between the MSE over single energy to noise ratio. The channel mean squared error decreases proportional to the symbol energy to noise ratio, and the symbol as a symbol energy to noise ratio is nothing but the collection of bit error, which is n times AB. So I'm gonna list the code that I'm using here. Firstly, I'm doing the encoding in order to do all kinds of FFT to do the convolution, and then I need to generate the symbol and doing the 7 precise as I mentioned in the architecture step. So the channel convolution and AWGN is in here. And the next step is receiver processing, and then I need to do the two algorithm which I mentioned earlier, LS and MSE estimation. And finally, I draw the two figure in the evaluation phase. So, in summary, there's a future work that we want to do. The first one is since the next generation of wireless technology, the 5G Wi Fi uses multi user MIMO technology, which is more advanced than we currently studying. So it is very interesting to further study this scenario to see if channel estimation can be a very good way for us to study where is a network. And the second one is the new approach to find out if there's new approach or more efficient algorithm to do the math. The next the main contribution here is in this project, I have simulate the OFDM cumulation system and then present a very direct view of relationship between the channel minimum square error, the channel MNC, and the single energy to noise ratio. And for this project, it gives me this very passionate motivation to think and study. I believe it's a beautiful yet challenging journey to continue studying various technology. Thank you.